Okay, this is the master video, Chapter 8, Section 3, and Chapter 9, Section 1. This video we're actually just going to cover Chapter 9, Section 1, because we're going to introduce this whole notion of solving a system by substitution. Well, before I explain what that is, I'll show you why we need it. Okay? It is often impractical to solve a system of linear equations by graphing. So here's a couple of examples. The size of the graph, not appropriate. So I'm just going to draw this freehand. So maybe you have a line that does this, and you have another line that does something like that. Okay. Well, if you're trying to find where they meet, this graph isn't really going to help you, because you're going to be guessing where that occurs somewhere out here. Right? So this doesn't work. Sometimes the solution, you can see it, but it's not easy to figure it out precisely. It's not easy to deduce. Here's what I mean. Maybe I have maybe a steep one like that. But the point is I'm looking for the solution. Where do these intersect? Right there. Well, where does that actually occur? Right? I can roughly guess where it occurs, but if I want a more precise answer, this just doesn't work. Okay, so graphing fails us here. So an algebraic method that is often used to solve a system of linear equations is called substitution. Okay. Substitution is one of two algebraic methods that you're going to learn. This one, however, is the first. All right, let's take the concert problem from Section 8.2, and let's actually solve it using this new method called substitution. That was the one where we had adults and children attending a show, and we modeled the system, but we didn't solve it. So these are the equations we came up with. It was A plus C equals 5, 6, 4, 3. So the number of adults plus the number of children equals 5,643 people. The other equation was the price of the ticket, so $15 times the number of adults plus $12 times the number of children. That's our ticket revenue of $79,059. Okay, so trying to solve this by graphing, no thank you. Okay, numbers are too ugly. So here's how substitution works. Step 1, isolate a variable of your choice. Okay, so we have two equations. Each equation has two unknown variables. Hint, choose a variable with no visible coefficient if possible. Well, why would I suggest that? Well, if you look at this equation, both A and C have coefficients in front of them. So if you were to isolate either one of them, you would end up creating fractions. That's not necessarily a bad thing, but your workload may have increased substantially. So look over here. Both A and C have an invisible coefficient of 1. So it actually doesn't matter which of these we isolate. We can choose. I'm going to isolate C. Why not? So I'm going to solve, which just means isolate. So solve for C. Okay. So to do so, I just need to get rid of this A. So I'm going to subtract A from both sides. So C equals 5, 6, 4, 3 minus A. All right. So I haven't really created anything new. I've just modified the first equation so that one of my variables is isolated. All right, next, step 2. Substitute your modified equation, that's this one, into the other equation. So the other equation is this one. Okay, it's the one we haven't touched yet. Okay. Well, keep in mind, if we're trying to solve a system, we're looking for the numbers A and C that work for both. That means that whatever C this is has to be the same as this one. So we're going to do a little swap. Okay. We're going to take this C, which is equal to 5, 6, 4, 3 minus A, and we're going to replace this C. I'll show you. So we get 15A plus 12. Okay, but instead of writing C, I'm going to write this C, which is equal to 5, 6, 4, 3 minus A. Okay, and of course that is still equal to 79,059. Now you may think this looks hideous, this looks really complicated. Well, I'd rather work with this because notice how there's only one type of variable in here. Okay, this equation only has A's. So this is now solvable using all the algebra that we've learned in previous math courses. Okay, so let's isolate and solve. So I'm actually just going to write that equation one more time. You don't have to. It's just so that I can see it. So 15a plus 12. And this was 5, 6, 4, 3 minus a. And that is equal to this. So I'm just copying it down again so I can see it. All right, let's solve for a. Okay, so here I'm going to apply distributive law. So I'm going to multiply each item in the parentheses by 12. So that gives me 15a plus, now there's a calculator icon here, so that means I'm going to use a calculator. So on a test, a question like this, I would let you use one. So this gives you 67,716. Next, positive 12 times negative a. Remember, I'm applying distributive law here. So this gives me minus 12a. And that's still equal to this number here. Okay, well, let's combine like terms. I have 15a minus 12a. That is 3a. That's quite simple. So I'm going to write 3a. But this 67,716, it's positive, I'm going to subtract it from both sides. So I get 3a equals 11,343. There we go. That's a piece of cake to isolate. Divide both sides by 3. These cancel, and I get a is equal to 3,781. Well, this tells us how many adults were at the show. There were 3,781 of them. Well, we're not quite finished. Remember, we want to solve the system, which means we want to find A, which we've done, and C, meaning we want to know how many children went to the show. So let's do that. So step 4, we need to solve for C using either equation. Hint, choose whichever equation looks the simplest. Okay? So remember, when you've solved a system, you have found numbers that work for both equations. Right? Well, I'm going to use this one because it's the easiest. C equals 5643 minus A. Okay? But I know what A is now. I just figured that out. That's what all that work was for. Okay? And so 5643 minus 3781 gives me 1,862. So we are done. So here I'll just put C here one more time. So let's just answer this in a sentence. So 3,781 adults and 1,862 children were at the show. Okay, and you can of course verify your numbers. You can add them together again and make sure that you get the total number of people, and you do. And if you want to check the ticket revenue, you're welcome to do so, but I'm pretty confident these answers are correct.